In Chapter 6, we'll explore how DIA provides solutions where traditional MS1 analysis can fall short. You'll see an example where overlapping peptide signals make MS1 measurements inaccurate or even unusable. Then we'll compare that to DIA analysis, where fragment ions in MS2 space allow us to accurately calculate deuteration despite the overlap. By the end of this chapter, you'll understand how DIA expands the range of peptides that can be measured, offering more reliable results in complex experiments.
I'd like to cover one special case where conventional MS1 analysis will fail, and DIA analysis can be used to still measure the peptide that is severely overlapped. So in this case, this peptide is a 2 plus that has an overlap of another 3 plus peptide. And this overlap is affecting the original peptide's third, fifth, and seventh peak in the isotopic distribution. If we were to measure this peptide based on the observed signal here, the duration measurement we would get for this peptide would be overestimated. And so most of the cases, this peptide would be a candidate for deletion, just because there are way too many peak overlaps to give us a proper measurement of the peptide duration from MS1 data. On the other hand, let's take the same case in DIA mode, right? So now we have the MS1 data, that's going to be the same. But now when we look at the DIA data in MS2 space, we can find that the peptide actually has quite a few clean fragments that we can use to calculate its duration. And so together, all of these fragments will give us the same exact information on the peptide duration, which is that it is absolutely measurable from MS2 data alone.
In Chapter 6, we saw how DIA can rescue peptide measurements when MS1 data alone falls short, giving us reliable results even in challenging overlap scenarios. In the next chapter, we'll look at side-by-side examples of clean data, minor overlap, and significant overlap, and explore how MS1, deconvolution, and DIA fragment analysis each come into play.